I'm a computer scientist by training, and I'm German, so I studied computer science at the university in Berlin, actually. And I did a PhD in computational neuroscience a long time ago. And during that PhD, I got into contact with a lot of the clinical parts of, at that time, neural network research and electronic health as one of the topics. From that studies at the university, I actually moved into the United States, and I spent there 16 years on the West Coast in San Diego. And I was working for 8 years in a company which was doing clinical systems and visualization research for universities, and another 8 years at UC San Diego as well. And during that time, I was very lucky to be part of a lot of research projects which were directed towards visualization and towards large clinical studies. One of them, for example, is the adolescent brain cognitive development study. It's very gratifying to be part of something that starts, something where you are part of the team that writes the grant and where you actually get the money to do something big. And after those 8 years in academia, mostly there was a very strong established collaboration already with lots of people in Norway. So I knew the country. I've spent vacations in Norway. I'm always trying to get to the north during any kind of vacation. So it was very natural for me to go after 8 years in academia on the West Coast to an academic institution here in Norway. Especially because I knew all the colleagues already from many years before, doing collaborations with them, visiting at least once a year for a long time. So it was very easy for me. There is also some personal reasons that I wanted to go back to Europe. And of course, that's important as well. My kids, they're both studying here in Europe, so it makes it much easier to actually come and visit them if it's not an additional 16-hour flight from a long distance. So yeah, I'm enjoying it very much. I came 2019 and I moved directly into the Hauke University Hospital. And in that position, I was part of the radiology group. And a lot of the radiology group is concerned about imaging in general and establishing diagnostic information based on MRI and CT image modalities. I was looking forward when I came here to be integrated into research endeavors that are already established. But actually it turned out that there was a lot of opportunity here in Norway to start new things. So as part of the Moon Medical Imaging and Visualization Center, there were a lot of grant opportunities that were coming up. And so we joined one of those grant efforts, and we were actually successful in the very first round of applications, which is something that never happens. So we have been working on a project which is called Workflow Integrated Machine Learning. And part of that project is to see how algorithms, established and new algorithms, can be better integrated in the clinical practice. As we all know, research and clinical practice are two different sides, and they require different expertise, and there is different general setups that have to be done. And one of the issues that we have seen in the past is that a lot of the development that is done in research takes a long time to arrive at the clinical end. And that is a real problem for any kind of clinical endeavor, that there is this magical 10-year border after which everything will be available, and it's very hard to get that additional step from a research project that shows the usability of a new idea into an innovation that is rolled out on a larger scale inside Norway. So the key word there is AI, and AI is foremost a promise. It's a promise of a new class of algorithms that will solve all our problems. And of course, we know that this is something that is not coming just out of the blue, and it integrates into many years of efforts to improve patient care. So in order to make AI something real, something that changes patients' outcomes, what we have to do is basically very similar workflows compared to what we have done in the past, where we have used advanced algorithms and segmentations to improve the diagnostic care, to improve outcome measures, and to find new ways of detecting specific illnesses, to integrate something like genetic research, biomedical science in general, into a workflow that touches patients. So they arrive at the hospital and then they provide helpful information. And part of that workflow, AI is supposed to enrich that kind of information. So if you're talking about AI in this sense, AI is this promise of solutions that is based on one essential ingredient, and that is the availability of a large amount of data. So this is basically, you provide lots of data, I will give you something useful. And that kind of promise has been shown to work with search engines. It has been shown to work with translation algorithms from one language into another. It has been shown with basically automatically generating high quality content in some cases. In some cases, it has also been shown that those promises come up with new challenges. So one of the things that PRESIMAL and PRESIMAL's goals align with that kind of new world of artificial intelligence is that we are able to attach to the data that we have in the clinic. And the data that we have in the clinic is, of course, orders of magnitude larger than what is available in research. And that means that just implementing AI in the clinical setting will make it much easier to generate the promised results. So we are working primarily in our projects in the integration of algorithms into the clinic. And this is something which has a long history, but it's especially nice to do this in the sense for artificial intelligence, because it's a field that has generated a lot of open source content. So a lot of people have access to very powerful algorithms, and the work is basically linking up data with algorithms. So what we are trying to do is not extract data as much from the clinical setting, but we want to move algorithms into the clinic. So the algorithms have to know how to connect to a clinical system. They have to know how to adjust to the local requirements. It's very easy for us to test this in a meaningful way because we have systems that mimic clinical systems. So those ones, they are kind of a safe environment for AI algorithms to participate in a clinical workflow that starts with patients being scheduled, patients arriving in the morning, patients going from one machine to another imaging machine, going to a doctor's office, and then finally going home, hopefully with a diagnostic, with a treatment plan, with follow-ups over time, hopefully being healed. So those workflows, they will generate in the clinical setting a lot of information. And by moving an AI algorithm into the setting, we are removing the need to anonymize the data. We remove the need to establish artificial systems that mimic this. So we actually want to provide an environment where the AI researcher is faced with all the diversity of real clinical data. That's a very good question because it's kind of the education is kind of the reason I'm doing what I'm doing. The joy to get into work and learn something. And a lot of this has to do with humility. You have to see that you're always the one who can receive a lot of the knowledge when you are facing any of these problems. The clinical setup is very special in that it's always integrates with a lot of different disciplines. So you are working together in a large team. You're working with technologists. You're working with radiologists. There are computer science experts. There are experts in machine learning. There are domain experts that are, have the required healthcare knowledge. And so being part of that team basically means that you always have to assume that everybody else in the room is more intelligent than you are. And I think this is a good way to get into a discussion about any kind of topic. Because the meeting was successful when you have learned something. And in our case, with our project workflow integration of AI algorithms and how to make them clinical reality, it's of course essential that we are not talking about theoretical problems, but that we are talking about things that allow us to test real scenarios, some specific disease group that we want to address, something which is not so much an exercise in generating a publication, like a publication record, but more an exercise in learning. And we have been very lucky that the radiologists in our group and in general, I have found them very social. And it's kind of surprising for me because a radiologist is usually somebody who is an expert in reading images. They're experts in sitting at a computer screen and not so much an expert in actually interfacing a lot in daily practice with patients. So it has been very nice working with radiologists, and mostly they are the source of real problems. So they have heard about the promises of AI. They have had experiences with it. So it's very easy because it's open source to do first experiments. And they are also willing to give a lot of their time. So they have a daily workload, and the research part is a tiny bit. But I found that they're always available. We have several rooms in our floor which are dedicated to radiologists, and you can go into any one of these rooms at any point, and you can ask very, very stupid questions. And they will be happy to show and happy to help. From my end, with background in computer science, of course, there are things that I can give as well. So there are things that I can try to solve, but they're usually in the context of very personal relationships with specific groups. And that has been, this kind of interaction, personal interaction, has been a very good model to feel that you move the field forward. Moving the field forward in terms of education is one of the things how we measure this. As a computer scientist, you're an expert in nothing. So we all know that being a computer expert sometimes means that somebody's email is broken and you have to fix email, or that there is a website that doesn't work and you have to explain what it means. So in that level, you don't really need to study, 8 years and get a PhD in this field. So usually what people do when they educate themselves in the field of computer science is that they very early on start to develop expertise in at least 1 or 2 other domains. And that could be genetics. For example, there's a lot of people who, do computer science and are very looked for in the term of genetic analysis, bioscience in general. And the same is true for radiology. So if you are spending enough time together with radiologists, you're hoping that it rubs off a little bit. Most of this is project specific. So instead of having a very broad education, computer scientists usually know something about, 1 or 2 organ groups. For me, this is the brain. So most of my research has been about neuroimaging, about a little bit cell biology. But if you are just looking for a computer scientist, that's kind of looking for somebody who, knows how to read email or how to use specific programs online. So I think the real expertise comes by specializing in a specific field. I think it's very similar than what a medical degree entails. You're also trying to get special knowledge. PhDs are used to get really deep into one specific field. And if you afterwards never stop learning, it's very easy to get a little bit better. And what you're learning is that there is so much more you don't know. So the humility comes back. But you learn also that there are some ways forward. There are some things that you openly have to say, I don't know, can you show me this? And there is not much magic afterwards if you have colleagues that are willing to interact on this level, then you can learn a lot so that at least you can judge a little bit what direction research would be useful, how you would be able to help somebody. And on that level, often the problems are very easy. So there is a big gap between research and clinical practice. And a lot of the methods that have been in many research studies are still not available on the clinical end. Just to name one example, we always acquire more than one image modality if there is a research study that looks at brain function. And the technical methods to merge all of the different scans into a single image, into a single view of the patient, have been established for at least 30 years. And those capabilities are so advanced that you can actually correct for a lot of the artifacts that you see in daily imaging that are based on physics and based on the machines that are actually doing the imaging for us. So if those algorithms are available in the research field, it is not obvious that they're also available for clinical routine. And most of this is because radiologists have been schooled over many years to read the images that come directly from scanners, instead of reading images that are going through post-processing, what we call post-processing, of adjustments, of corrections, of fused views that merge those together. So they have the ability to look at two images side by side and form a picture in their mind. And research projects have invested a lot of efforts in, overlaying two of those images and making them one. And that's one of the promises that we hope we can bring to people. This doesn't sound very much like AI, but it is part of the basic workflow, and it's part of something that allows the radiologist to judge the quality of algorithms. And AI is one group of those algorithms, and therefore those tools hopefully will be useful for the radiologist in the future. Yeah, so this is a very difficult question. Is establishing national platforms the best way? I think there are, as always, many different answers to this. Foremost, what we need on the national level is an exchange of ideas. So we have to be able to utilize what other people have done. We have to be able to use the expertise of somebody who has experience in a specific field at all the other hospitals in Norway. Something like this, PRESIMAL is one example for a group that has this goal, that will collect contacts, that will provide a platform to inform somebody. Here is a site that has a hospital that is a specialist in a specific field, and therefore we're willing on the platform level to interact with everybody else in Norway. This doesn't really stop at on the country level, of course. We know we're part of an international community. There is the Nordic Alliance countries where we have a lot of contacts that reach outside of Norway into all the partners in the north. And then, of course, there is on the next level Europe, where we have established lots of collaborations directly with research groups, for example, in Germany. I myself, I have a lot of contacts with the US still. So every one of those outreach efforts is one way to scale our expertise. So if somebody has to be educated in a specific field like AI, then where do we go? Where is somebody who we can go to a conference to, or where is somebody who we can invite to talk about their solution? And something like this, I think international or national efforts are a good way of doing this. The flip side, national efforts, I think, is in terms of data security. It is something that is very essential to our work, because without the trust of patients in the security of their data, we will not be able to continue any of our research. So it has to be at the forefront of how we do business. And a national platform has very strict requirements on how access is granted and who is supposed to be part of it. So we feel that in some of the specialty areas, I think plurality of solutions is a better way of establishing progress. One of the examples is for our health region here, the Western Norway health region. We are providing system services that link 30 different healthcare institutions together. And it's very gratifying that I'm able to walk into 30 different hospitals, and I will be able to use my username and password. I'm able to access all the imaging devices on those systems. But this is something that on the organizational level is part of the health region. In order to establish national solutions, I think it is a good strategy to start with health region solutions that are duplicated across health regions. So something that works in one health region should be established freely into another health region, but there should also be ownership on the algorithms, on the development, on the data, on systems in that health region. So I do not think that just always going national is the very best way of doing this. Definitely that's the case for education, for getting contacts. We have to work on the national level there. But in terms of integrating solutions, I think there is many local solutions where something like open source and open data are initiatives that very well map to a plurality of systems. This is kind of something that is dear to my heart. The integration, testing, and development. There are like 3 different phases. They're usually portrayed as something that you can do independently. So you start with planning and you integrate at the very end. I have found that it's actually not a good model. We know from computer science that they started with something where you have development phases, where you are, plan for 2 years to be really sure that everything is right when you finally implement it. And it has been shown that our progress is too fast for this type of development. 2 years is too long a time to plan an integration. One of the basic issues with this is that the hype of AI is probably 2 years old. And that means if we now start testing AI after 2 years, we will be behind the curve. So instead of doing phases for this type of development, what we suggest is to use an integrated approach, to use systems which are as close as possible to clinical systems and that allow us to work in a cycle. So we will do very quick prototyping. We will establish some algorithm based on test data. We will immediately provide the first version of that to our clinicians, to our radiologists, because they have to provide feedback that is essential to direct the development. So if we do not get the feedback immediately, we will spend lots of time improving things that aren't essential and not looking at things that are really important for a successful outcome. There have been many projects who have generated at the end PowerPoint, PDF documents, something like manifesto of what we want. And we have found that it is more helpful to start building something that does a tiny bit of what the great vision is. If you start with this level, immediately you will get feedback, and immediately you will be able to what we call fail fast. So you like systems where you can test an idea, and after a week you can say it's like, no, we have to change how we approach this. This is not good enough. And I enjoy this, to have the people on board that make that kind of fast turnaround possible. And I think we have to use that kind of approach instead of big, long projects if we want to compete, if we want to move what we know is possible in research into clinical practice. It has to become second nature.
So if you could look into the future of artificial intelligence, when do you think that these solutions could actually improve patient care?
Yeah, I think this is very easy to answer. So if I'm looking at AI systems currently, then they are kind of mirrors. They're systems which we look into and they show us something we want. And I think where AI often fails is in telling us about its limitations, in refusing to show us a picture if they are not sure. So that type of making AI, artificial intelligence that is intelligent, that actually knows something about physical properties, it would be a very big step forward. So what I wish would be an AI system that critically looks at the input it gets, and that will refuse to provide a nonsensical answer. This is something where we are relying on education for radiologists at the moment. An AI system very often is one where you can provide lots of different types of input, some that make sense and some that don't. And these kind of trick questions, they're used in order to understand the limitations of the system. So you have to get into a dialogue with an AI system in order to understand where its borders are. You have to say, it's like, oh, so if I show you an image and you tell me this is a brain, can I flip the image around and are you still telling me it is a brain? And there are AI systems which are specifically trained, which can be fooled by very simple operations, like flipping an image, like adding or removing information to the corners of those images. That type of fooling a system is very dangerous potentially if you have very high expectations. So the label AI and the expectation of intelligence in such a system has to be, you have to live it. You have to be able to go to an AI system and explore. It's a process that every one of us has to go through at the moment. It is very time sensitive. You have to be able to send lots of data in order to actively find the cases where the system will break down. So in the future, all the AI systems, they will be able to detect something like this. They will say, it's like, this doesn't look like something I've ever seen. I cannot give you an answer. And with that kind of feedback built into AI systems of the future, I think it will become much easier to trust them. It will become much easier to live with the limitations of such systems. And we all know, I remember my experiences with the first, language, translation services, dictation systems, which if you're not a US citizen, it's very hard to use them. And a lot of progress has been done in this sense in some of the fields, but we know that especially in the clinical field, we will have to go through the same process. We will be faced with a lot of AI systems that do not tell us their limitations. And a system where ethical recommendations, where domain appropriateness is part of an AI solution, that is something that I strongly suggest we will have in the future.